Hi guys, back here with Chapter 5. We're going to take Chapter 5 and break it up a bunch. Chapter 5 is nearly 60 slides long, and I think it's probably some of the most important information we're going to cover all semester. Might even be one of the most important chapters we cover all year. So I want to make sure that you get it in chunks, and that they are digestible chunks, so that you're not trying to digest some 2.5 hour lecture about macromolecules, because the things that we are going to see in this chapter, we are going to continue to see throughout the rest of the year in many different aspects. We're going to see it at the end of this semester. We're going to see it at the beginning of next semester. We're going to see a lot. So I want to make sure that you do have an understanding of what exactly it is we're getting into. Take it nice and slow, okay? So, that being said, let's go ahead and jump right in. I have no other reason than to do just that. A lot of this stuff is stuff that you would have heard about or done in Bio 1. Now the difference here is that we're going to cover it in about 3 days, and in Bio 1 I think you guys would have taken them maybe 2 or 3 weeks. And it was difficult back then, and we're going to cover it at least the same depth, maybe a little bit more in depth in some aspects of the information we're going to cover. What we're going to cover today in this first part is going to be very small compared to what we're going to cover in the next 2 videos. We are going to spend time discussing today the types of reactions that make large macromolecules. Okay, so do keep that in mind, that today is just a taste of what we're ultimately going to get into later on. That being said, it is still going to be extremely important in the grand scheme of things, because the stuff we learn today is going to continue to play out and be seen in many of the other chapters many of the other topics we cover in this chapter as well. Here's a list of the essential knowledges, the stuff that you guys are supposed to have learned after we get done with this chapter. And again, these are very broad statements that have far greater and more detailed explanations, so do keep that in mind. And we got 2 sides of them. So this chapter, I'm going to go back to the title slide, deals with the structure and function of macromolecules. Okay? Now the term macro means large, and if you attach it to the word molecule, we're talking about large molecules. That might seem a little bit like an oxymoron, but there are things that are large molecules, and then there are things that are small molecules. Oxygen, for example, would be an example of a very small molecule. And carbohydrates of many different varieties would be examples of big molecules or macromolecules. Okay? So, knowing that, let's talk about what we are going to do to start to build these large molecules, because these large molecules are put together from smaller things. Okay? These large molecules are generically called polymers. Okay? A polymer is a word that we can also break apart. It's one of the reasons we do those word roots, right? I hope you're keeping up on those, by the way. But the term poly means many. The term mer is a word root that means part, so it's many parts put together into a larger molecule, and those smaller subunits are bonded together. Okay? Now, polymers are made up of things called monomers, right? You probably have heard this term before. That prefix mono means one, okay, or and then mer again means part, so one part. Okay? A monomer is a subunit of a polymer. Now, when we want to create a larger molecule, a polymer, we have to use many small polymers. If I had a little drawing tool that wasn't terrible, I would draw a chain link fence. That's what I'm going to attempt to draw up here. It's not working. Let's see. No. I don't like it. I do have, and I will do this, might as well do this since this is going to be a short one anyway. I do have the document camera, which I will go ahead and pull up real quick. So when we think about polymers, what we should always think about is we're making something bigger out of something smaller, okay? So I always think of, it's way too dark. All right, so I always think of a chain link fence. And many of the molecules that we see in this chapter are going to look kind of something like this. This is super generic, obviously, but each one of these links in the chain would be the monomer, and this actual chain itself would be the polymer. Okay? If I had a working drawing tool, I would have drawn that on the previous slide. All right? So do keep that in mind. That's what we're talking about when we discuss polymers and what they're made up of. All right? And we're going to discuss, we're going to eventually get into very specific polymers. All right. So the way that we link these monomers together is by something known as a covalent linkage, okay? Also known as a bond. Covalent linkage is a fancy term that means a bond. Okay, it's a very specific type of bond. It describes exactly what kind of bond it is. It's a covalent bond. But it is a bond between monomers that is formed in the creation of polymers. Okay? Now, making these bonds happens by way of a process called condensation or dehydration synthesis. You can use either one of those terms to describe the process by which monomers are joined together. Okay? Condensation reactions or dehydration synthesis reactions happen when monomers are covalently bonded to one another by the removal of a water molecule. Okay? Now, we've got to remember that when we are linking these monomers are not just like little chains, right? They're not just like little chain links, actually. They're actual organic molecules. And those organic molecules have carbon, they've got hydrogen, they've got oxygen. And they've got it put together in specific ways. Now, if we want to link a monomer and a monomer together, like that, what we would ultimately have is some kind of interaction that would yield a water molecule falling off of those constituent monomers that we see right here. And as a result of that bond being formed, water will be removed. Okay, so that's where that term condensation or dehydration actually come into play. That they are extremely descriptive of the process that's occurring. So when we say the word condensation reaction or the word dehydration synthesis reaction, those descriptive words tell us what's happening. Okay, so think about, a couple weeks ago it was 90s, right? You take, and this happens now, even if it's hot enough for this to happen now. You are thirsty, you get a glass full of ice, you put water in it, and all of a sudden the water seems to be on the outside of the glass. Well, what's happened is there's been condensation created, right? Or if you get up in the morning, you are made to park outside because your parents park in the parking in the garage or whatever, and you wake up and there's water all over your car. Well, where did that water come from? Okay, well, that water was removed from the air and placed on your car. That's where that water came from. It was actually in the air at one point, and it was removed from the air and deposited onto your car. Okay, so that's one way of remembering this. Okay, dehydration is another great way of remembering it. When you are dehydrated, what has happened to your body? Your body has lost water, right? Water has been removed from your body. And so both of these terms tell you exactly what's happening in this type of reaction that builds a polymer from monomers. Okay, I really, really like this picture here because it shows you exactly what's happening with a condensation reaction. Okay, the top picture right here shows a short polymer that's already been formed. And what we're doing is we're linking these little monomers. Okay, these little purple guys are the monomers. Okay, And I like it because it expands on the simplicity. It shows, yes, these things are simple. Okay, it's a purple circle, right? But it also shows that, you know, inherently they are organic molecules. They have some oxygen, some hydrogen attached to them in some part of their structure. And we want to attach them to this growing polymer right here. And one thing you'll notice about this growing polymer is that there's an H here, and there's an OH here. Very similar to what we see in the unlinked monomer. There's an OH here and a H over here. Now we bring that monomer in. We're going to try to attach it to this growing chain, this growing polymer, right? And we're going to put these two things in close enough proximity where ultimately there will be some bond formed. A covalent linkage is what the notes called it in the previous slides. And what we see here is that the OH of this monomer comes into close enough contact with this H from the short polymer, the short growing polymer, and the H and the OH combine to make water. Water goes away. It's removed from these two entities, right? So here's one entity, here's the other one, and that water molecule is just literally removed. Okay, it's not like a droplet of water, right? It's too small for that. It's a single molecule of water. But as a result, this bond right here is formed. This is the covalent linkage that's talked about. That's a covalent bond, okay? So this monomer right here, if I could put an X on it with a nice drawing tool, would be the exact same one that you see down here, only now this is part of a larger polymer, a larger growing chain. And one thing we notice is that this H here and this OH here are still there. So we could theoretically and feasibly think about adding more monomers to make this chain get bigger, okay? And that's something that's going to come into play when we start to look at how we build some of these big macromolecules that we're going to talk about specifically, like proteins and lipids and things of that nature. You're going to see this process play out over and over and over again in the notes that we follow up in the next two videos. Okay? So condensation synthesis or dehydration synthesis reactions are ones that build polymers from monomers, and they do this by the removal of the water molecule from ultimately both constituent parts. Okay? The other half of the story, if we are building polymers from monomers, we also need to understand how our body breaks down polymers into monomers, because that's just as important as us building polymers. We want to be able to break them down. For instance, you eat animals, right? I mean, if you are a meat eater, you eat an animal, okay? If you eat chicken, you eat chicken meat. Pardon me, if you are a meat eater, you might eat chicken meat. You might eat cow meat. At the core of what that meat is, the muscle fiber is going to be different from our own. We want to be able to take those muscle fibers, those things that we ingest or put into our body, and we want to be able to make them into whatever we want to. Okay, but to do that, we have to break them down first, right? We can't just take that muscle fiber from the chicken or from the cow and incorporate it into our own. We have to break it down into its constituent parts and then reuse it how we see fit. And the process by which this occurs is called hydrolysis. Okay, so this is the other half of the picture. We just talked about the half of the picture that gets us to build these bigger molecules in our own bodies. Okay, let's talk about what hydrolysis is. Hydrolysis is one where polymers are broken down into monomers. And again, we can get some meaning of this word. Maybe you had no clue what hydrolysis meant when you first saw this, but if you understand what these word roots are, and notice that we continuously see these word roots over and over again, what you're going to ultimately see is that now this word has a little bit more meaning. Okay, so if we break that word hydrolysis into hydro, meaning water, okay, and lysis or lyse, okay, is oftentimes one that you'll see, means to loosen or break apart. You get hydrolysis or hydrolysis, which means to break with water. And that's exactly what happens in these types of reactions. A hydrolysis reaction means you're going to break something apart with a water molecule. Water is added and the lysis of the polymer continues or occurs. okay? So we are actually using water kind of like a pair of scissors in this case. All right, another really good diagram that we see right here is the exact opposite reverse of what we just saw in the previous diagram. Okay, it's like they just took it and flipped it upside down. We have this growing or larger polymer molecule that we see up here. Okay, and we want to break it down. We want to take that chicken meat, if you want to call it that chicken muscle, we want to turn it into our own muscle, but to do that we got to break it down into its constituent parts and then rebuild it, right? So what we do is we take a little water molecule and I'm going to say apply it to this bond right here. That term apply is code for me not having a complete and total understanding of the chemistry that occurs at that particular point. That is a Mr. Bergman, Mr. Christofferson question. Okay, they can give you the biochemical breakdown of the reaction that happens there if you really wanted to know. I'm here to tell you that you don't necessarily need to know that from my class, but you need to know that a water molecule can be added to this particular bond, okay, this particular part of the chemical, and it will break this bond right here, almost like little scissors. And what it does is it adds a hydroxide group or a OH group to the end of this molecule here, right, which is what we see added here, and then this molecule kind of floats off and goes away. All right. The other H from water is added to this guy right here, as we see here, and this one's going to go do its own thing. Now we could do that at every one of these bonds. You can add a water, okay, and then this one will break off there. You could add a water here, and then this one will break off here, and then you get all of these little monomers that make up the that would have made up that larger polymer. Okay. So this is a process known as hydrolysis, and it is the complete opposite reaction of the condensation dehydration synthesis. Okay? Hydrolysis means to break by way of water. Add a water molecule and the thing breaks. Okay? It's as easy as that. Now, in the upcoming videos, we are going to talk about the different classes of organic molecules. We're going to talk about carbohydrates, proteins, lipids, and nucleic acids. These are our four major classes of organic molecules. We're going to talk about how they're created, what are the monomer or constituent parts. We're going to talk about how those constituent parts come together to form the polymer. We're going to discuss what those polymers are called. We're going to discuss what are some of the structures and functions of those polymers. And in my opinion, it's really kind of interesting when we take what we just learned in these kind of introductory chemical reactions that kind of drive all of these large macromolecules to be created. We're going to talk about how we put them together and then ultimately what is their function once they are put together. And so you're going to see a lot of what we just went over. You're going to see stuff that looks like this. It's going to be much more complex. It's not complexity that you have to worry about memorizing, but you're going to see complex molecules and diagrams, and you're going to see this part here. You're going to see waters go in and break stuff. You're going to see waters drop out of molecules. Okay, so do remember that you should maybe go back and review this if you've forgotten this, because I will refer to condensation or dehydration reactions in the next two videos. I will refer to those when we discuss all of those four major classes of macromolecules, because in just about every single one that I can recall, those reactions take place to build those large macromolecules you see in front of you from smaller constituent parts called monomers. Okay, so I will leave you with that, and in the upcoming videos we will take carbohydrates and proteins and address them separately from lipids and nucleic acids in the third video. Okay, have a good one, guys, and I'll see you soon.